All right, we're moving on to section 14.5. It's basically what we're going to look at here is the volume of spheres. And there's a formula here which is derived really nicely in our textbook. So if you go to the iBook and you go into the section, you can see a nice little explanation for how the actual formula for the volume of the sphere is derived, if you're curious. So, but I'm going to start out by just telling you what the volume of the sphere is. It's 4/3 pi r cubed. And when you get to calculus, you can hopefully you'll be able to see the relationship between the volume of a sphere and the surface area of a sphere. But obviously we're not there yet, so let's just take that formula, the volume of the sphere, and let's apply it to a few problems here. First problem there, you're talking about the volume of a sphere, which has a surface area of 16 pi square inches. So if I know the surface area, I can use the surface area formula. So surface area is equal to 4 pi r squared, which we learned earlier in the chapter, and that's equal to 16 pi. And what I can do from that is I can solve for the volume. So divide both sides by pi, the pi's drop out. Divide both sides by 4. I'm going to end up with r squared is equal to 4. So my r is going to be equal to plus or minus 2, but we know that the radius, of course, cannot be negative. So the radius is equal to 2. And then I can take that and plug that into my formula for the volume of a sphere. So its volume is equal to 4/3 pi, and then I'll plug in 2 and cube it. And if I simplify this whole thing, I'll get 32 pi over 3, and I'll leave it in that lovely form. An exact answer. Next problem here is talking about the volume of a hemisphere, half a sphere, which we talked about when we were talking about the surface area of a sphere. And so the volume is going to be half of the volume of the sphere, 4/3 pi r cubed. And I'll simply take that radius of 6 and I'll substitute it right there for r. And if you do the math on it, it will simplify to 144 pi. Now you're going to see some word problems, kind of like this one here. Finding the volume of an empty space in a box containing 3 golf balls. So if I stick those golf balls in that rectangular box, what you'll do here is, of course, you'll take or hopefully you'll see that you'll need to take the volume of a rectangular box and simply subtract 3 of the volumes of those golf balls. The diameter of each ball is 1.5, which means that our radius is going to be half of that. So radius is equal to 0.75 inches. And so I'll start with the volume of the box, and I can see hopefully that the height of the box I can find by taking all these diameters going all the way across all 3 of these golf balls. And so it'll be a length of 1.5 times 3. And then I know that this length right there for the box will be simply the diameter, which is 1.5, and the same thing this way will be 1.5. So the volume of the box will be the length, 1.5 times 3, times the width, which is 1.5, times the height, which is 1.5 also. Multiply all those together, and through the magic of previously doing this, it'll be 10.125. Now I'll need to find the volume of these balls, these golf balls here. So the volume of the golf balls, and there's going to be 3 of them, so it's going to be 3 times 4/3 pi r cubed, and that of course is simplified. The 3's will drop out, so it's just 4 pi r cubed, and that's going to be equal to 4 times pi, and I know my radius, which we had found up here, is going to be 0.75, and of course I need to cube that. Plug this into a calculator and I get 5.301. Now we're not getting an exact answer here because you know, when I take 0.75 and cube it, I'm going to end up with just kind of something kind of yucky. And then when I subtract it, I'll end up with something even yuckier, so I'm not going to do that. I'm just going to go ahead and get an approximated answer here for this one. And so the volume of the empty space, as we had mentioned, was going to be the volume of the box minus volume of 3 of the golf balls, and that's going to be just equal to, I will take this number right here and this number right here, and I will simply subtract them. And I'm going to get 4. House rule in our class is to round to the 100th. 4.82. All right, let's jump to the back and let's see if there's anything back there that we can try, and before we let you try some problems. Okay, let's go ahead and try a couple problems on the back side here. We have a hollow rubber ball for number 5 here, and the outer radius is 11, and the inner radius is going to be 10. Find the volume of the rubber used to make the ball. So what I'm going to do is I'm going to draw like a 2-dimensional drawing of this, kind of like a cross section, and you can see here that my inner radius is going to be 10, my outer radius is going to be 11. And so really what I need to do here, if you think about it, it's going to be to take the volume of the outer sphere, and I'm going to subtract the volume of the inside sphere, or the empty space. And so I'm going to get 4/3 pi times 11 cubed minus 4/3 pi times 10 cubed. And if I do some of the simplifying here, I'm going to get 4/3. I mean, what I'm really going to do here is factor out a 4/3 pi. And then what I'm left with is basically 11 cubed minus 10 cubed, which is going to be 331. And if I go ahead and keep on simplifying this, I'm going to get 441.3 repeating pi. And if I ask for an approximated answer, you can go ahead and multiply the 441.3 repeating and multiply that times pi, and then just round that to the 100th place. All right, we'll try one more problem on here. Let's try problem number 7. You've got a basketball that's in a box that's shaped of a cube. The volume of a basketball is this, and the edge length of the box is equal to the diameter of the basketball. So your volume here is going to be equal to 4,500 pi, and that's equal to the volume formula, 4/3 pi r cubed, and basically I'm going to solve for the radius. Okay, and really, because what I really want to do here is find the diameter of the basketball so that I can use that as my edge length of the box. Okay, and then so if I simplify this, divide both sides by pi, I can multiply this side here by 3/4, and therefore multiply this whole thing by 3/4. And so my r cubed, when I do all that, is going to equal 3375. And then I take the cube root of both sides, or I figure out what times what is equal to 3375. It works out nicely as 15 is my radius. The other thing you can do on your calculator, if you're curious how to do this, is I could take 3375 and I can raise it, use the caret button on your calculator, raise it to the 1/3 power. And you're going to have to put 1/3 in parentheses there. And that's the same thing as cube rooting. And you'll find out next year when you get to Algebra 2 why that is true. When I find the radius is 15, I know that the diameter of the basketball is going to be double that, which is 30. And now I can just go ahead and I can find the surface area of the box. I can find, the area of one side of the box. I know there's 6 sides for the box. So the area there is going to be 900. And then multiply that times 6, so it's going to be 5,400. That's going to be my surface area. And then the volume is just going to be length times width times height, where each part is going to be 30. So I just do length times width times height, and I'm going to end up with my volume from that. So 30 times 30 times 30. Okay, and then just plug that in your calculator and you'll get the answer for the volume of the box. If you're looking for a challenge, problem number 8 is a great problem. It's actually a great 4-level problem. And number 6 is also a tough problem. You're going to need, for number 6, you're going to need a formula for the spherical, it's called a spherical cap. And you can look that up. I wouldn't worry too much about problem number 6. All right, and then you can go ahead and try some of the problems from the book. I'm going to let you go ahead and do that right now. All right, take care.